Welcome back to the show, everyone. As soon as I start, everyone starts talking. It's great. A bunch of markers. All right, here we go. So we're going to graph some logarithms, and we're going to graph some complex ones. And what I want to do is take a log that's not base 10 and describe it, or take a log with a multiplication in there, because we know what kind of shift is that going to happen in the inside. That's going to be a horizontal dilation of 1/4. Remember, it's opposite. But sometimes they don't like to do that. Sometimes they like to talk in like, let's make it not even a horizontal like translation. We are going to change this into a vertical translation. Can I graph a shrink easily? Can I sketch a shrink easily? No. Can I graph a translation, a slide, a shift easily? So would there be an advantage to me changing this from a shrink or stretch to a shift? Watch. Do you guys think I can do it? All right. So this is my g of x, right? By rule, this is 4 times x, correct? If I'm multiplying, what can I do with my logs? If I'm multiplying, I can add. So can I rewrite this as log base 2 of 4 plus log base 2 of x? Can I do that? Not distributive. Stop saying that. Stop it. Stop it. That's not, it's actually the product rule because it's based on exponents. All right. I don't care anymore. All right, so here we go. Now what did I just do? I did that pretty quick in one step. Not only that, this is not a number yet, right? How can I simplify this? Yeah. 2 to what power equals 4? So this is 2 plus log. What did I just do? I took a horizontal dilation and changed it into a vertical translation. So now think about this. If this, don't judge my graph world. I'm just going to draw a sketch. If this is my original graph, we'll call this f of x equals log 2 of x. Don't look, it's not to scale. It's not bad. I don't think it's not right. It should be a little bit shifted down. But what am I doing with this point based on what I just did? Shifting it up too. So I took something I can't do a quick sketch of and answer questions on easily, and I made it into something I can answer questions on easily. Yeah. You're going to get a lot. Oh, for this? You'd either have to use the change of, remember your calculator does log base 10, so you'd either have to do this, or you'd have to hit the math button and scroll down, and scroll way down, and there's a log base button. Also, if you wanted to, not use a calculator on this, you could graph it, because log base 2 is pretty decent to do. But when we answer questions most of the time, do I need exact values, or do I need end behavior, asymptotes? Zeros, right? Like those are important stuff. So it's important that we can sketch this stuff really quickly. You know what I mean? Oh, I did it. Describe. How did I change my outputs? What a mess. How do I describe my output in terms of input? What increased my x or my y? Y by what? 2. How does that relate to my input? This is a weird question, I know. How does the output, my y, deal with my x? So x increases by 1, what happened to each of my y values as I go up by 1 to my original? Would they go up or down by? 2. Oh, I should have said input output, but this should actually be acceptable, right? Because x is input, y is output, right? They are the same thing. Y values increased by 2. Not super worried about this, but the person who made this packet, shout out to Jean, I don't know her, but they actually went through AP tests and made sure there's a type of every question seen on every practice test in the notes. That's why there's some weird worded stuff periodically, if you guys have noticed. She did a really nice job, though. Thanks, Flamingo Math. She's going to find me now and say I can't make these videos and post them publicly because I'm an embarrassment to the profession, she said. All right. Let's do 12B. What? That's probably true. That's probably true. I'll tell you a funny quote that someone told me at a different time about myself. All right. So now we're going to do the same thing, but different. Instead of changing it to a translation, we're going to take a function that I wouldn't know how to graph and change into one I do know how to graph. Because we know how to graph basic logs, right? But when I throw an x squared in there, it gets me kind of confuzzled and scared. And I'm already scared enough. So is there a way I can rewrite this to have just a basic log base 2? What do I do with my exponents? So I can rewrite this as 2. Because this is something I know how to graph. And then what's the 2 going to do to it? Stretch. So is this something I can sketch and answer questions on now? Yeah. So my G, let's draw my basic one first. Oh, that was actually not bad. Oh, no, I got it. Oh my gosh, because these are my points. I actually did it. Boom. Eat that, camera. All right. I don't know. Because they always hate on me. The camera hates on me. All right. So that's my f of x. What's g of x going to do? Up 2. So actually, if I want to take my original, I double each of these points, right? So if this distance is 2, I go up 2. That's 3, so I go up 3. It's double the size, right? So if I have a sketch, I just double each point, right? I double each y. So when I do that, this is my best work I've ever done. If I wouldn't have said that mean stuff to the camera, I would have submitted this for like evaluation. To be like, hey camera, nice job. All right, so we graphed it. Now describe the change. Can you guys see if I write down here? I feel like Julia has to like look through this and me. Can you? Is this in, or whoever? Just I'm in the way. That's what everyone says. As x goes up by 1, what happens to my y?
Y doubles.
Y doubles. As every time x goes over, my y value is increasing by doubling. You could say we multiply y by 2, or it gets increased by a factor of 2. Yeah, there's more ways to say it. I like saying double, so. All right, how's this so far? Almost, yeah. All right, so y doubles. You get that. We actually might get ahead.
No way.
No, we might actually. Okay. This is the one I'm not gonna lie, debated skipping this one, but I want to do it.
Come on, yeah, we gotta get it.
No, absolutely not.
Yes.
I'm going to show this to you guys because I think I'm going to show it, but I'm not going to spend a lot of time on it. Does that sound fair? Because I want 5s in this room. Everyone who gets a 5 brings me joy.
What if I get a 3?
Waka waka. Yes. You guys bring me joy just by being here. I'm not lying. Oh, geez. Whatever. All right. So let's say given this one. This is why I don't care for this as much. We're taking an example I know I can graph really quickly. You know what I mean? Like this is something you look at and be like, oh, I can graph that, right? No problem. But we're going to do something with it that makes it gross. So what I'm going to do is I'm going to take this problem, because anytime you move exponential or a logarithm, you're actually also doing a dilation to it as well. And we're going to take this and we're going to show that there's a vertical dilation on this of a natural log. Okay? This might be a multiple choice question. It's like, is there an equivalent to this function, right? What's my change of base say? It's right here, right? Yeah, I showed you this thing. So that's my change of base formula. So this is my x on that example, and this is my b, right? So my change of base would be natural log of x minus 1 over natural log of 2. Oh, Jiminy Crickets, I know how to write. Right? Now again, older calculators don't have, do you know how, like you said, how do I graph this? This is how you'd have to graph it if you didn't have a calculator that had a base change function. You know what I mean? Multiple choice. I've seen this before on other pre-calc, like in my old book. It would say which expression is equivalent to the original. That one is. Now that natural log of 2 is a vertical dilation, right? Because natural log of 2 is a number. So I could rewrite this as 1 over natural log of 2 times natural log of x minus 1, right? So there's the vertical dilation, because 1 over natural log of 2 is a number. Yeah. Yeah. I didn't want to cause confusion for something that's not used a lot, but it can be used. So when I go to graph these, am I going to graph it using this? Heck no, I'm going to go like this. Ooh. Let me get my points now because I feel better about myself. Don't. All right. So that's my original, right? That's my f of x. So what do I do with x minus 1? I shift it to the right one, right? So every point just goes right 1. Now, how would I describe this? S is always as x goes up by 1. Y goes to the right 1. What? It did, but they always want output. These are always as x goes up by 1. Because they want to know as you change your input, what's going to happen to your output. That is exactly what you'd put, though. Goes right 1 from the parent function. Let's do it. Or, you know what? No, I digress. Good video. What I'd like to give you guys is